Let's understand frictional force. A ball rolling on a ground stops after some time due to frictional force between the ball and the floor. Friction slows down the movement. After applying the brakes, friction increases and motorcycle stops. A ball travels a greater distance over a tilted floor than a carpeted floor. The smoother the surface, the lesser is the friction. A striker on a board, when the striker comes in contact with the surface of the board, the friction force comes into play. Friction force is a parallel component of a contact force between any two surfaces, and it opposes the relative motion or tendency towards such motion of two surfaces in contact. A force F is applied on a block moving on a frictionless track. When F is only horizontal force on the block, it accelerates with A equals to F by m. Now, force F is applied on the block on a rough track. The block is at rest. However, a rough track, the block does not move initially on applying force. F equals to Fs and F less than μs into normal. Clearly, the body remains at rest because some other force come into play in horizontal direction opposes the applied force F, resulting in zero net force on the body. This force Fs parallel to surface of the body in contact with the rough track is known as static frictional surface. We can use equation 1. As we increase F, Fs also increases, but this happens upon a certain limit. Fs max equals to μs into normal. Once F equal to Fs max equals to μs into normal, the object starts moving forward. Instead of friction, a new type of friction tries to oppose a relative motion between track and the block. This friction is called kinetic friction and denoted by Fk. Fk equals to μk into normal and acceleration equals to F minus Fk by m. But since μk is less than μs and Fk is less than Fs, the block moves forward with acceleration A equals to F minus Fk by m if F is greater than Fk, or constant velocity if F equals to Fk. Fs does not exist by itself. It comes into play the moment there is an applied force. It is not motion but relative motion that friction force opposes. Fs and Fk are both independent of area of contact. Now, let's understand why friction is helpful. It would be impossible for us to walk without friction. Without friction, we would slip as soon as we try to walk. It is very difficult to walk on smooth and polished surface. Frictional force always act in the direction opposite to relative motion. Without friction between the tires and roads, vehicle would skid. When the driver presses brake pedal, the brake shoes rub against the rough surface behind the wheel. This produces friction which slows down the wheel. When we write with a pencil, friction force between the point of our pencil and the paper makes tiny particle of carbon rub off the tip and leaves the mark on the paper. We require friction to light match. If we strike a match on a smooth surface, it would not light.